three objects are connected by massless wires over a massless, frictionless pulley as shown in the figure. The tension in the wire connecting the 10 kilogram and the 15 kilogram objects is measured to be 133 newtons. Okay, so that's this tension right here that you can see. It's pointed to. 133 newtons is that tension. What is the mass of M? Okay, so this mass over here, we're asking for that mass first. And then what is the tension in wire A over here? All right, so before we start this question, we need to think about whether we need to do rotational kinematics here. Okay, the question tells us that we have a massless pulley. If the pulley is massless, then we don't need to do rotational kinematics. That's when we can treat this whole thing as one big system if we wanted to. Okay. If the pulley did have a mass, then we would have to find the moment of inertia of the pulley and then use Newton's second law for rotation. Net torque equals I times alpha to figure out this problem. But this question says the pulley is massless, so we don't need to do that. All right, so let's begin. First, we're going to try to find mass M. So we're going to start by drawing a free body diagram of this object over here, the 10 kilogram mass. And the reason why we're doing that one first is because we know what all the forces acting on it are, so we'd be able to figure out what its acceleration is. Since everything is attached to each other with this rope, then or with this wire, then we know that their accelerations, all three of those masses have to have the same acceleration because they're all stuck together. So let's look at mass, the 10 kilogram mass. I'll draw a free body diagram of it. So what forces are acting on it? We have a force of gravity, and I'll just calculate that force right now. It's mass, so 10 times 9.8, so it would be 98 newtons. And we have a force of tension. And the question tells us that the force of tension is 133 newtons. Okay, so maybe I'll call this one T1 over here. Okay, so we know all the forces acting on this object, then we'd be able to find the acceleration. So let's write F net equals ma. Well, we can see just by looking at this that T1 is bigger than Fg, so the thing is going to accelerate upwards. So we're going to say then that this direction is the positive direction, and in the case of just the 10 kilogram object, up would be positive then. So what is our F net? We have one force pointing up, one force pointing down. We're saying that up is positive because that's the direction it's actually going to be moving. So we would have the positive force, 133, minus 98, since it's pointing downwards, equals the mass of the object is 10 times its acceleration. And we can solve for the acceleration. So I have 133 minus 98, which is 35. Divide that by 10 and we get 3.5. 3.5 meters per second squared and upwards, since it's positive. Okay, so now that we know what that is, we can move on to the 15 kilogram object if we like now. And what is that going to help us with? Well, if we know the force of tension pulling down on it, and we know the acceleration, we'd be able to find the force of tension pulling up on it as well. And we'll call this one T2. Now, what do we know about T2 and the T over here, tension pulling up on this mass? Well, since this pulley is massless, those two tensions are going to be the same. Okay, so once we find this T2, we've actually solved part B of the question. Okay, so let's move on to this 15 kilogram mass. We'll draw a free body diagram of it. Okay, so what do we have here? We have a force of gravity, which is equal to its mass, 15 kilograms, times gravity, 9.8. We also have a tension, T1, so I'm just going to point it downwards, T1, and it's equal to 133 newtons, which is given in the question. And we also have another tension pointing upwards, which we're calling T2. Okay, we have to stay consistent with our signs. So if we said positive was upwards before, we have to stay consistent. So we'll say positive is upward here. F net equals ma. So we have T2 that's pointing upward, so that's positive. and then minus, we have 133 newtons, that's pointing down, and we have 15 times 9.8, which is pointing down, equals the mass of the object is 15 times the acceleration we already found from before was 3.5. Like we said, they're all connected together with a wire, so they all have to have the same acceleration. So I can solve for T2 by bringing everything to the other side, and I'll just type it all on my calculator. 15 times 3.5 plus 133 plus 15 times 9.8, and I get 332.5. So that's the answer for part B. 332.5 newtons. If we look at significant digits, there's 3, 4, and 4. So my answer should only have 3, the fewest number of those significant digits. So I'm going to round it up to 333 newtons. Okay, so we can solve for part A now. There's a couple ways to do it. We can treat everything as one big system, but since we know what the acceleration is and what the tension is acting on that mass A, then that mass capital M, then we should be able to find out what the actual mass is. So let's move on to M. I'll do it over here. So this is M. So if I draw a free body diagram of M, what forces do I have? I have a force of gravity, which is equal to mass, capital M, times gravity, 9.8. And I have a tension force, which is tension A and also equal to tension 2. So I'll call it tension 2, which we just solved for is 332.5 newtons. Okay. And we know what the acceleration is here, because again, everything has to have the same acceleration. So this time, we're going to say pointing downwards is positive. Okay, so if these two masses, the 10 and the 15 kilogram masses, are moving upwards, then the capital M mass must be going downwards. Okay, so down is positive. So what is my F net? I have Fg, which is 9.8 M, that's the positive one, minus 332.5 is equal to the mass, which is M, times the acceleration, which is 3.5 meters per second squared. Now I'm going to bring all the m's to one side, so I have 9.8 m minus 3.5 m equals 332.5. And now I can solve for my m. So 9.8 minus 3.5 is 6.3. Equals 332.5. If I divide both sides by 6.3, then I get 52.8. Okay, again, everything had 3 significant figures in the question, so my answer will also have 3 significant figures. And that's all. Thanks for watching.